this video, we're going to look at more libraries, but we're not going to look at random anymore right now. We're going to look at a different library called time. And so as the library name already suggests, it's dealing with time. So let's just see what that can do. So what we're going to do is we're going to use the import keyword, and we're going to import time, just like this. So this imports the time library, and this allows us to do a lot of time tracking and stuff. And we're going to look at two kind of specific functions inside, and I mean there are of course many more, but these are two kind of very common and very cool functions. And the first one that we're going to look at is going to be time.clock. And so what this gives us is it gives us the current processor time, which isn't, I mean, it doesn't really tell you much because it's not really defined. It's defined by another function inside that's written in C. So the processor time itself maybe be that informational to you. So if we, for example, just print out, so if we go into the time library like this, and we access clock function, and it's a function, so we open and close parentheses. So if we run this, we'll see, we just kind of get this number here. Now this doesn't really tell us much. It's actually the processor time, but like I said, it's defined by another function that's written in C somewhere, so like that may not really tell you that much. But what we can use the time.clock for is we can use it to measure the speed of algorithms. So I'm going to show you how to do that. I'm going to show you how to kind of give a time value to how fast your algorithms are running, so that you can kind of keep track of it. And maybe if you're running long code, you can see, well, how long does one loop take? One loop takes 2 minutes, and I'm running, I don't know, 30 loops, so I'm going to be back in an hour. So maybe for that purposes, but just to kind of give you a feel of how things are going and how long things need. So yeah, so how would we go about that? Well, what we can do is we can save the current processor time in a variable. So we can create a variable called current time, and we can make it equal to the time.clock, like this. And now what we can do is we can, well, let's just say we want to print hello, and now we're gonna look at the time after that. So past time is equal to, and now we want to save the current processor time. So we want to take the time.clock now. So what this does, the time.clock, is it gives us the current processor time in that moment that it's being called. So in this time, for example, we call it once, and we maybe store this number inside. At a later time, we call it again, and we call a number that's bigger, and we store that inside. But we always use this time.clock. And now what we can do is we can print out the time difference. So we can print out the past time minus the current time. So what are we doing? What we're doing is we started a program and we saved the initial processor time in the current time. Then we printed out hello. After that, we printed out the processor time afterwards. So we saved the time, we did something, and then we saved the time afterwards. And now what we're doing is we're printing the difference in the time. So this time is measured in seconds, and so what we're doing is we're taking away from the later time the earlier time, and this kind of gets rid of this offset, and it gives us this absolute value in terms of, or it gives us this relative value in terms of relative time taken to do this feature here, so this print function. So if we run this, what we see is, well, you know, it took 0.0002 seconds to do this print feature. And if we print out something else, so print out world, and if we run our program again, we see now we get a bigger time. And so if we run it a couple of times, we're not always going to get the exact same time. As we see here, sometimes it goes faster, sometimes it goes slower. And that really depends on other processes going on too. So I mean, we're seeing pretty big differences here relatively. So all the way, from 0.001 to 0.009. So that's almost an order of magnitude or 10 times a difference. But we're all still within this order of magnitude, this kind of millisecond range. So the 0.000, that's going to be the millisecond range after that we're going to be in, or well, not even. So we're actually going to be smaller than milliseconds that we're going to be in. So we're going to be under this millisecond range, and so that's kind of the order of magnitude that we're going to be in. And so this is what this, even though this time clock or this algorithm time may change a little bit, it's not going to change drastically. And so this little bit of change is really due to underlying processes that are actually going on inside your computer and stuff. But at least it gives us a good idea of how long this takes. So this doesn't take a second. This doesn't take a tenth or a hundredth or even a millionth of a second. This takes not a million, a tenth, a hundredth, a thousandth. This takes 1/10,000th of a second. So that's what we see here. Yeah. So this is the time.clock kind of feature. The next thing that we can look at is a time.sleep. So what we can do is, well, what the time.sleep does is it sleeps for a certain amount of time. So the computer kind of sleeps before it does something else. So let's say after all this happens, let's print 1. And then what we're going to do is inside the time library, we're going to call the sleep function. And now what this does is, we can already see by the kind of guide that popped up right here, is we need to put in a number here, and that's going to indicate how many seconds we want to sleep until we do the next thing. So afterwards, maybe let's print 2. And let's run our code, and then let's see what happens. So we run our code, print 1, and then we wait a little bit and we printed 2. So if we make this time window maybe 3 seconds instead of 1, and we run it again, then we can see it clear. So we wait, and now we print 2. So what this time.sleep does is your program sleeps for just a little bit. And so in this case, it sleeps for 3 seconds, and then it kind of continues. So it takes a short break for this time interval that you're giving it here, which is in seconds. And so that's another cool thing that you can do. You can kind of do certain timings with this. So here we can measure algorithm time, but here we can also add a little bit of timing to our computer or to our program. So what we can do, for example, is maybe we want to print out a counter for 10 seconds. So every second we want to print out, a number that corresponds to the second. So we can write a little for loop. So for, let's just call our temporary variable I. So for I in range from 1 to 11, so we want to go from 1 up to 10, let's just print out this I number every second. And so that's kind of going to print out one number every second, so it's going to kind of print out second by second the number. So what we want to do is we want to print out I, and then we want to sleep our program for a second. So we want to go into time.sleep, and we want to sleep for 1 second. So what we're doing here is we made a for loop, and we used our dummy variable I, and we're going through 1 up to but not including 11, so from 1 to 10, and we print out this number, and after we printed this number, before we continue with our loop, we make our program sleep for a second. So it holds for 1 second, and then it goes on. So if we run this, well, first we see this 3 second break here. And now we see 1, 2, 3, 4. So every second we're printing out a number. And then it's going to stop at 10. So what we see here is this is just a kind of simple way, obviously, to kind of print out the seconds. But you can do a lot of cool stuff with that. Maybe you want to add some timing to your program. Maybe you need to use timing. Maybe you want to wait a little bit before something happens to make sure you get something, and then you can continue. So this is what you can use this sleep functionality for. And it'll probably become apparent of its use when you most need it. So it's really great to know. This sleep function is really great to know, when you need it. Maybe sometimes you really need these interval breaks, depending on what it is. You can obviously make it variable too, so instead of putting 1, we can put I in here, so that means we're printing out the number, and then that indicates how many seconds we're going to sleep for. So, well, we sleep for 3 seconds here first, since that's what we created. And now we sleep for 1 second, now we sleep for 2, now we sleep for 3, now we sleep for 4 seconds, and then we bring out the next output, and now we're going to sleep for 5 seconds. So this is kind of a variable way to kind of control sleep. And so let's just run our program before it goes on too long. Cancel our program. But you can kind of see here, you can do a lot of cool things with the sleep, and you can put in, you know, you don't have to put in just one input. You can kind of make that variable depending on what you like. And you can kind of let your imagination take over and, you know, expand on this however you like or however you may need it. And this time.clock feature is extremely useful in terms of measuring, you know, how long your program takes to run, maybe identifying areas in your code that take longer to run. So let's say you have, you know, you're running 5 or 6 different loops. Maybe you want to measure the time it takes each loop to run, and then you can compare the time it takes the 5 or 6 different loops to run, and you can see which one, you know, is taking the longest, which one should you focus on if you want to reduce the time of your program the most. So those are also some kind of cool features that you can use.